In these problems, we are being asked to find the points on a curve where the tangent line is horizontal. So if we think about it, you've got a curve that looks like that. Where are the points where the tangent is horizontal? That means where the slope is 0. These are actually important points to look for on a graph because it's that point where the slope changes. So something is special is happening. So these are kind of special points. The way we do this, where the slope of the tangent line is horizontal, that means the slope equals 0. And of course, the slope of the tangent line is given by the derivative of a function. So if we take the derivative of the function and then find out where that derivative equals 0, we'll have those points. And they want the x values for those points. So let's see how this goes. We're going to take the derivative of this first with the power rule. So 3 times 2/3 is 2. And then we lower the power by 1, we get x squared. And then this is x to the first power, so that 8 is multiplied by 1, so it stays 8, and the x goes to a power of 0, which means it disappears. And of course, negative 21, the derivative of a constant is 0. So this is our derivative. So where does this equal 0? Well, you could find out by setting it equal to 0 and seeing if you can solve it. And so I guess the first thing I'd do here is subtract 8 from both sides. And we get 2x squared equals negative 8. You could divide that by 2. And you get x squared equals negative 4. And maybe you wanted me to stop already because you can't square something and get a negative number. So it looks like there are actually no points where there are horizontal tangent lines. And that is one of the choices. You can choose none. So that's what we would choose here. Just to verify this, I plugged in the original function into a graphing calculator. And here it is. It's a cubic function, but it's one of these that's very steep, and it never goes flat in the middle like some of these cubic functions do. So there is no point where the tangent line is horizontal. It just keeps going up very, very steeply all along its length. So I would encourage you to use graphing calculators to verify your hunches, check your work. I think they're a good tool. All right, let's try another. Oof, boy. So here we've got a 4th degree polynomial. And I guess the first step would be to take the derivative. So we're going to get 4x cubed minus 24x squared minus 4x plus 24. And then we'd want to figure out where that equals 0. I think I'm gonna factor out a 4 first, just to make this a little bit simpler. So x cubed minus 6x squared minus x plus 6, and we set that equal to 0. So how are we going to do this? Well, you might remember that the possible zeros of a function are all the factors of the constant term over all the factors of the highest term. The highest term, the coefficient is 1, so the factors are just 1. So we're going to have 1 over 1, 6 over 1, 2 over 1, 3 over 1. And if you're doing this without a graphing calculator, I guess you'd test all of those. Actually, I can just kind of see very quickly. If we put in a 1 here, we'd have 1 minus 6 minus 1 plus 6, and that would equal 0. And let's see, does negative 1 work? Oh, it's positive negative of all these two are the possibles. Does negative 1 work? So that'd be negative 1 minus 6 plus 1 plus 6. Yeah, it would too. So 1 and negative 1 are certainly points here. But there might be others, and I don't know that I want to go to the trouble of testing all these in this kind of complicated, hard to crunch out equation. So I think at this point, I'd probably just use a graphing calculator. And what I did in this case is I just chucked in the derivative. So instead of looking for the place where the slope of the tangent line is 0, we'd actually look for the zeros of this function. And you can see we've got negative 1, we've got 1, but we've also got 6. And so if I had plugged in 6 here and cubed it, and et cetera, and done all that calculation, I would have gotten a 0 there as well. So I think it's okay to use a graphing calculator in that way. So if you're in my class, you've got my permission to do that. So that's a little bit of work with finding the points on a curve where the tangent line is horizontal.